Hello everyone, this is our problem minimum cost walk in weighted graph. This is today's Leetcode POTD. This is a graph question in which you have to given a undirected weighted graph with n vertices which labeled from 0 to n minus 1, and we have to given a vector edges in which edges of I represent u of I, v of I and w of I, where u of I and v of I is basically edges that is basically nodes in between edges exist, and w of I is basically weight associated with uh, that edges. Okay, so a walk on a graph is a sequence of vertices and edges. The walk starts with a vertex, and each edge connects the vertex that comes before it and the vertex that comes after it. Okay, this is an important line. This is given. It's important to note that a walk may visit the same edge or vertex more than once. Means we can visit same edge or vertex more than once. Okay, remember this line. The cost of walking starting at node U and ending at node B is defined as the bitwise end of the weights of the edge traversed during the walk. In other words, if sequence of edge weights encountered during the walk is W0, W1, W2 and so on Wk, then the cost will be W0 and W1 and W2 and so on and Wk, where and is basically a bitwise AND operator. Okay, this is then after we have to given a query array in which query of I represent S of I and T of I, basically starting vertex and ending vertex, and you have to find the minimum cost of the walk. Okay, if there is not exist a path, then answer will be -1. So we have to return the answer where answer of I is equals to minimum cost for the query of I. Okay, uh, since in a graph we know that if graph is connected, then there is always be a path between any two vertex. So if there is not any path between between two vertex, means both the vertex are not in the same component. So if vertex is not in the same component, we have to return the -1, because you cannot go from one vertex to other vertex because they are not connected to each other. So I hope you understand when our answer will be -1. So our answer will be -1 when both the graph is not connected. Okay, let's see the example 1 and try to understand the problem. Okay, this is example 1. I hope you can able to see it. Okay, this is example 1 in which given n is equals to 5 and edges given 0 and 1 connected with edge 7, this is, and 1 and 3 connected with edge 7, that this is this edge, and 1 and 2 connected with this edge. Okay, 1, and you have to find the weights from starting vertex 0 and 3, means we want to go from 0 to 3. What will be minimum weight? So there can be multiple paths, like you can go from we can go from 0 to 7 by this path, visiting through this node, and you can also go to from this and this path. Okay, and since if you visit any node any number of times, it is stated in the question. So as we know that in AND operator, the AND of an array, like if there are n elements, we are taking AND of it. So AND will be minimum of the minimum element, like if we are taking AND of a b c d, so AND will be less than or equals to the minimum element. So by this property we know that if we increase the number of nodes in my AND, like if we increase, let me write it. Okay, yeah, if we increase number of element, then and will be lesser. Okay, so if you increase the and will be lesser, so in this case what we will do, since we can visit every node more than once, so we can take we try to take all elements weights, because if if we take the elements, so our answer will be minimum possible. So what I will do, I will what I will do for that, I take and of weights of same component, and if starting and ending vertex is in same component, then if starting and ending vertex in the same component, then our and then means resulted answer will be and of all the component, like here this will be 7, and of 7, and of 7, and of 7, and of 1. Okay, so if two vertex like starting and ending belong to the same component, then our result will be and of all components weight. Okay, I hope you understand it. And if two component is not connected, so and will be -1 because we cannot visit them. Okay, so if two connected is not connected, like if two nodes here, that is example curious second, where 3 and 4 is not connected. Okay, 3 and 4 is not connected. So if 3 and 4 is not connected like here, so we cannot go from 3 to 4 by any path, because there is not exist any path. So we have to just return -1. And if there is path between any node like this and this, I will just take the and of all the values. So here first asking for 0 and 3, so I have to go for 0 to 3. There will be exist two path. First path, that is and of 7 and 7. So as we know that and of same value will be same value, so this will result in 7. So yeah, this result in 7. And another, that is and of 7 and 1 and 7. So another path will be and of 7 and of 7 and of 7 and of 1, because I am going to note second now. So as we know that the minimum value between all the 7 and 1 will be 1, and since 1 the bits come, the set bits in 1 also coming in 7, and so our answer will be 1. I hope you understand it. My approach is, if the two vertex for which I am finding the cost, if they are connected, so our answer will be cost of all the paths in my connected component. Because like if this component, you ask any node, like between these any number of nodes, any set of nodes, I have to just return the and of all the values like 7 and 1, because this will be minimum. And if they are not connected, we have to just return the -1, because we cannot visit them. Okay, I hope you understand it. Let's go to the second example. Okay, this is our second example. You have to give an total number of edges is nodes will be 3, and edges equals to 0 and 2 of weight 7. This is this node, and 0 and 1 with the 15 weights. This is this one. 1 and 2, this is by this 6 weights, and 1 and 2 connected by weight 1. Yeah, okay. So query is asking what will be minimum weight for 1 to 2, and as we know that there is exist multiple path between 1 and 2. So let me introduce you. One path is simple, that is this weight of 6. So let me write it. Total path between 1 and 2 is there will be many paths between 1 and 2. So one let's suppose it's simple. If I going to 1 to 2, one weight can be 6. If I can go to 1 to 2, one weight can be 1, because of, as you know that this node 6 node, this is node 1. We can also visit with this path. So let me write 1 to 2 by 15 and 7, and then 1 to 2 by, if I can read from 15 to 7 by this path, this path, this path, and then we can also beat by this path. I am going from 1 to 2, then I am going from 2 to 1, then I am going again from 1 to 2. Okay, like it is given in the question that we can visit any edges or nodes multiple times. So for minimizing that and means cost, I will first go to 1 to 2, then 2 to 1, then again 1 to 2. So our answer will be 6 and 1 and 6. Okay, so one path also always one path is also possible, that is 15 and 7. I'm going from 15 to 7, then I'm going from 6 to 1 to 2, basically 2 to 1, then 6, then and 1. Okay, this is all the possible paths that can exist and have the different set of ends value. Okay, so let me write the set of ends value. We will try to find the minimum value from this. Okay, and of 6 will be 6. Let me erase it. And of 6 will be 6. Okay, and of 6 will be 6, and of 1 will be 1, and of 15 and 7 is equals to 7, and of 6, 1 and 6. As you know that 1 is odd and 1 is only a single set bits, that is 0th bit, and 0th bit is not set in the 6, so and will be 0. And since and of 6 and 1 and 6 will be 0, so here 1 and 6 will be and equals to 0, and 15 and 7 will be 7. So 7 and 1 will be 0, so this will be 0. So the minimum cost will be this one. Either you can choose this path or this path. So what my approach is, I tell you first that my approach will be, I take and of all the values like 15, 7, 6 and 1. I already told you about this. I will take the end of all the values. So this value also giving me 0 answer. So I hope you understand that my approach. I will take the end of all the components, like in the graph there is component A, there is component B, there is component C. Okay, and in any value that if a source node and target node will be in this component, so and will be and of all the component exist in this graph. If source is here, target is here, so we cannot go from source to target because they are disconnected, so we'll just return the -1. So I think you understand my approach. Let's try to code it. Since in this approach we have to check that they are connected or not connected, so for this I am using disjoint set union. I am using this DSU approach because it will help me to find out whether they are connected or not connected. Okay, let's go to the answer. Let's try to put it. You have to give n number of nodes and edges. Let's try to first DSU code. We can write here. Okay, let's write the DSC code. I am using disjoint set, so I will just resize parent and initialize with the n because there will be n vectors vertex, sorry, and size I'll say initialize size array with n comma 1. Every vertex have one size, and what I will do iota parent dot size, sorry, parent dot begin and parent dot end comma 0. What I will do, I am doing basically for I is equals to 0 to I less than n, I plus plus, parent of I is equals to I. So this is the STL for what it will do. It will initialize my all the values from 0 to n minus 1 with the value 0 to n minus 1. I hope you know this. Then what I am doing, since in the disjoint set you have to do two operations. First is join and other is finding the parent. So first I write the parent and find p. In terms of the parent, what I will do, if parent, sorry, I will take a node. So if parent of node is equals to node, so I will just return if this node is a parent of itself, so I'll just return the node. Else I will return parent of node is equals to find p parent of node. I hope you understand this is the path compression. Okay, then what I will do, I will try to join it. So void union unions, let's say int u and int v. So what I will do, I will find the parent of this. Pa is equals to find p of u and pb is equals to find parent of v. So if pa is not equals to pb, so if pa is not equals to pb, then what we will do, we will marking the parent of, like if pa is equals to pb, then I will just continue it and return it. Okay, else if what I will do, if I will find the size. So if parent of pa is greater than parent of pb, basically not parent, a size, means if the component size of pa is greater than component size of pb, so I will just add pb size in the pa because pa size is greater. So I will just I will just add size of pb component in the pa, and I will mark that parent of pa is equals to parent of pb, basically parent of b component is equals to pa. Okay, else we will do this, like size of pb plus equals to size of pa and parent of pa is equals to pb. I hope you understand this approach. Okay, I think all this is correct. Okay, so let me write. I will first make constructor disjoint set ds of and. Okay, then what I will do, I will take a, since I have to find the end of the component, I will make a vector of size n for the component. Okay, so vector int component and is equals to n comma, I will just initialize with the int max, that will be int 1 to the power 31 minus 1, means all values will be set. Okay, so I'll first visit all the edges. So for it is equals to edges. Edges is the type of u and v. So int u is equals to itf0 comma v is equals to itf1 comma w is equals to itf2. Okay, so if they are not connected, like I'll find the parent of pa and pb. So int pa is equals to find ds dot find p of u, and pb is equals to ds dot find p of b. Okay, so if their parent are not equal, means they are not in the same component. So if pa is not equals to pb, so if pa is not equals to pb, then I will add in my, I will union the two nodes. So ds dot unions u comma v. Okay, after in the union I will take end of it in my component. So what I will do, after this I will mark my component end with the weight, sorry, int equals to w, that will be weight, w is equals to active2, and component, since it will be vector, so I will take u, and component and of v and equals to w. Okay, this, if they are connected like this, so I will take the and if pa is not equals to pb. I hope you understand it. Okay, let's go for the queries array. Okay, for auto it is equals to query. So query of type of starting ending vertex. So int st is equals to itf0 and ending equals to itf1. If they are not connected, so if ds dot find st, if their parent are not same, ds dot find ending. So if the parent is not same, so what I will do, I will just since I initialize my vector answer with the size of query dot size. Okay, I hope you understand, because we have to return the answer with the size of query. For each query you have to return the answer, so I'll just return -1. So what I will do, if the parent is same, so if the parent is same, our query of I will be component and of ds dot find st, means their parents, like as you know that in the disjoint set, the end of all component will be at the parents. So I am finding the parent of both. Since their parent is same, so I take any starting or ending and finding the end of the components. Okay, and this is also a case like if our starting equals to ending, so we have to just take query of I is equals to 0. Sorry, it will be answer of I. Yeah, answer of I is equals to 0. Answer of I is equals to 0. I will just return the answer after this. Okay. I hope you understand it. Let's try to run it. I think, yeah, my code will be should be correct. Let's try to run it. Yeah, disjoint set. Let's find mistakes. We can take the 30 edges. Oh, okay, auto. I have to take auto. Yeah. ds dot union. Okay. Find p. Yeah. Find p. Basically find parent. So I make the function find p. So I have to call the find p. I think my code should give the correct answer. Let's try to check why it's not giving the output. Okay. Okay, let's try to run it. So, okay, give me a second. There is internet issue. Let's try to run it. It is giving me the wrong answer. Like I am returning the answer 7. Okay, I think I am making a mistake. Yeah, not component of view. It's basically component of parents. So components of PA and components of PB. I think I'm making some mistakes. Like what I'll do, I'll find the parents of U and B now. Okay, let's try to see if the correct or not. I think this should give the correct answer. It is giving me 7. What is the case? Okay, I think I have to just remove this. Okay, let's try to run it. Because I don't want to only take unique values. It means if a graph is connected between two nodes, we have can take another values which like here in example second graph is connected first with the value 6, but we can also take the value of 1. So let's try to submit it. Yeah, it is giving me the wrong answer. Let's understood where it is going to the wrong. Okay. Okay, I find the mistake. The mistake is here. Basically, if parents are same, like if parents are not same, so if means basically they are two component and they are union, they are going to join. So we have to take end of both the component. Here I am just making the mistake. So if parent of P equals to PB, so I don't have to union it. I'll just take the AND. Okay, I'll just take the AND of it. Else they are not, if they are not they are not in the same component, I have to take the AND of both the components. So what I will do, component of AND of P, first I will join it, ds dot union u comma v, then parents of PA and is equals to PA is equals to components of AND of PA and components of PB, component and of PB and W, because I have to take the AND of PA and of PB and W. Let's also do it with the component of PB. Okay, let's try to run it. Okay, let's try to submit it. Yeah, this is accepted. Let's talk about the time complexity. Time complexity of my solution, it should be O of n log n,